Hey folks, welcome back. This is Joel, and in this video we'll look into we'll actually do a little bit of network automation and kind of take a break from our regular intense networking, right? We'll talk about pyATS in this particular video, right? So pyATS is a very interesting, think of it as a test automation framework, right? And I've been using it for some time now to do some of my day-to-day, I've been using it in some of my day-to-day scripts, right, or day-to-day automation tasks. So I thought maybe I'll do a quick video on how to install it, how to do some basic, how to connect to the devices, write probably a couple of scripts, right, and we'll see where it goes from there. All right, so that being said, let's all the information which you need is right here on the DevNet website, right, developer.cisco.com. Go down to /pyats, you'll get to the homepage of pyATS. You've got a lot of examples, right? A lot of examples on code exchange, right? And the documentation, right, which you need is right here on the center, right? You have the pyATS documentation, you have the Genie docs, and something very new which they have right now is Expresso, which is kind of like a dashboard for running all your test cases and all of that, right? So we'll look into pyATS and Genie mainly, probably not Expresso that much. So coming to some of the documentation around this, so this is the pyATS main doc, right, the main documentation page, and on the left hand side you will find the links to various other sub documentations, right? You will find the core infrastructure, which is important, the Genie library guide, and so on, right? Now, what is pyATS to begin with? It's this. I think this kind of image kind of clarifies that. So on the top is your integration, which is basically if you're writing a Python script, that would come here, right? But not just Python. You can I don't know, maybe integrate your pyATS with Ansible as well, right? Or maybe any other kind of CI/CD pipelines and any other kind of, maybe you are writing a web. You have a web framework that also can integrate, right, on the top. But the main meat of it is actually in these two layers, right? So the Genie is nothing but so the whole pyramid here is basically together called as pyATS, but it has, like I said, a bunch of components. Genie and the corresponding SDK, right? You can use Genie and SDK by itself as well, right? So Genie has a lot of parsers. So maybe if I have the page open here, yeah, there you go, right? So this is basically showing us all the various parsers which people have written till now, and this is a very active community. So people are writing parsers day in and day out, right? So you also can contribute by writing a parser, and if it gets approved by the pyATS team, they'll basically add it here. So you can select whichever operating system you have here, right? You have a lot of Cisco operating systems. I see Junos as well, and couple of these even I don't know, right? And Viptela and all of that. So you can basically write parsers, right? It's pretty simple to write parsers, and that's why this particular layer on the top here is contributing to the whole framework. That's the main place where you write the parsers, where you include the new protocols, models, and all of that. And this is the library framework for the for the libraries, or for the, like I said, for the parsers and all of that which you write, right? It kind of gives you that agnostic feeling, right? Which means by invoking this library, I can just say, hey, go and collect BGP from my network, and it will basically go to every single device, figure out which operating system it is running, and then it can it can get you the outcome, right? So you don't have to write a separate script for, I don't know, maybe Nexus. You don't have to write a separate script for iOS, XR, XC, or Junos, right? You can have just one script, use the framework, use the library framework, and you can kind of let the system decide and figure out, and it's intelligent that way, right? And the bottommost layer, this one is the core test infrastructure, right? So this is mainly for writing your test cases, test definitions, and it also gives you a very nice report at the end of the day, right? So if you're writing individual scripts, you can directly use Genie, right? And then if you're running some kind of test cases, you would generally use pyATS, right? Test cases are nothing but, I would say it's nothing but a bunch of tasks, right? So you might want to do some testing with your device, right? You might want to enable a new feature in your network, maybe say, I don't know, maybe NTP. You want to enable a new feature, and then you want to also make sure that nothing breaks, right? So you can define a test case to do that. You can say, let's go enable NTP, test these things, and then, you know, obviously go and disable NTP and again test if the situation is all good. So you can define your own custom test cases like that, and you can for doing that you can use the pyATS, right? Maybe we'll not see test cases in this video. Maybe if I have time, I'll do another detailed one on test cases later. But for now, we'll mainly concentrate on pyATS and Genie, but from a very, you know, how you can use this in your day-to-day scripts, right? To do some of the simplest tasks, right? So that's what you're going to check. All right. So this is the main documentation, like I said, but so you can get to all these links right from here, right? I'm sorry, from here on the left-hand side, you've got all your documentation pages. I've just opened them one after the other just to show you, right? So that being said, let's, okay, what topology do we have here? It's a very simple. I have a Nexus 9K and couple of, you know, CSRs over here, right? So, okay, I think there's a small spelling mistake here. It's supposed to be CSR. Okay, so we've got Nexus 9K 1, CSR 2, CSR 3, and I don't know what they have. They have probably some BGP running, I guess, right now. Let me check. So it's, I think the username password on this one is admin. Yeah. So if I'm not wrong, they have some kind of yeah. So they have BGP running. Or let's just look at show IP route. Yeah. So they have EIGRP and BGP running, right? Pretty simple. So in the I have the underlay kind of a the IGP which I've used is EIGRP. So that is basically the loopback 0, which is 1.1, 2.2, 3.3, right? For the whole 3 devices, you know, is advertised in EIGRP. And then we have BGP, which is running on top of it, and the other loopback, which is loopback 1, is advertised in this BGP. That's it, right? There's nothing else. So they just have EIGRP and BGP, and we are going to use these 3 devices for our testing, right? So let's start with first what? Let's start with clearly installing pyATS, right? So right now, I mean, these are just 2 windows. I like to have 2 windows, so I'm just going to keep it here. Let me just clear the screen a bit here. Yeah, there we go. Hope this is visible. It's big enough. Cool. So what we're going to do is let's create a new folder, right? I'm going to call this guy as, I don't know, bits please underscore pyATS, right? Awesome. So we have created that folder. Let's get inside that. And I like to use virtual environments whenever I'm playing with Python, right? So, and what Python I'm using right now, I think it's 3.7. Yeah, it's 3.7, right? Just want to make sure if you are following through, you can do the same as me as well. All right, so we've got 3.7, right? So that's good. What else should we do next? Okay, so let's go about installing this virtual environment, right? It's basically nothing but Python, the module which is v, right? And since I'm already inside the folder, so I can just do a dot, right? So now it's going to install. Think of virtual environment as a small instance of Python. Why do you do this? Because this way I can have my multiple projects, different projects running in different Python virtual environments, right? It won't cause trouble to my other existing Python projects. So that's why I like to create new virtual environments. Cool. So once you're done with that, you can just source it, right? Your sourcing is nothing but activating that, you know, environment. So right now I activated, and you can see the prompt has changed over here. So which means we are good. Next, let's install pyATS. It's pretty simple. It's just one command, right? Pip install. And if you are using Z shell like me, probably you might have to put a quote like this, right? pyATS, and you can mention it to be full installation, right? So let's use full. So if you are probably just try, if you're using bash, I think this quotes might not even be needed, right? Try it without the quotes. But if you're using Z shell like me, so I'm using, you see on the top here, I use Z shell. So in that case, you might need the quotes. I'm going to hit the enter here, and so there you go. It's trying to collect, it's going to download and install a bunch of things. I'm going to come back in a minute once this is done. All right. So looks like the installation is completed. The other interesting thing which I like to also install along with pyATS is it has nothing to do with pyATS as such, but I like to install it because IPython, right? You guys probably know about it. It's an interactive way of, you know, sending Python commands, right? So that's something which I like to do as well. So let me install that. I mean, again, this has nothing to do with pyATS. If you don't want, if you're already using an IDE and all of that, you probably don't even need this. So yeah, give it a minute. Alright, so IPython is done as well. Cool. So I think we are good to go ahead, guys. You can see everything which we need is going to be there here. So in fact, let me create a new folder inside my workspace. I know, maybe let's call this as and let's call it as codes, right? Maybe that is good. So yeah, that's good. So let me clear the screen a bit. Okay, so we are inside the folder codes, and we are gonna try some basic stuff, right? So first thing, when you have to connect to any device, in our case, what devices we are connecting, these three devices, right? So when you have to connect to any devices, you need what they call as a we need a testbed file, right? So there are different ways of creating testbeds, right? You can manually create it. It's nothing but a YAML file, or you can use pyATS, the create testbed utility as well, right, to create it for you, right? So we'll actually do that. But there are different ways to do it, and you can see in one of the documentation, I don't know if I've opened it here, there are quite a lot of ways of doing it. So maybe I think it's on this one, yeah, connection, yeah, I think this one, or probably this one, yeah, I think this one. So you have if you go to the testbed options here, you will find a lot of ways to create the testbed, right? You don't have to really do it manually. You can do it in different ways. You can check it out from here. If you have a list of devices in your CSV file, right, with the corresponding, I don't know, maybe SSH username passwords, then you can create it from there as well, right? So but then in my case, I'm gonna show you one way of doing it, right? So let's say we're gonna call pyATS, right, and the utility is called, I think, create testbed, if I'm not wrong. Yeah, pyATS create testbed and interactive, right? So this way you can and then you have to give the name for the output file, which is going to be output, and I don't know, maybe you can give the name as testbed.yaml, right? Okay, so now what it is going to do is let's go and click enter. Give it a second. All right, so my screen was a bit stuck, but I think we are back. pyATS create testbed interactive, and the output file, which is testbed file. Okay, let me do one thing. Let me just cancel this. Let me go inside the codes folder, right, which I was earlier on. All right, so here let's run the same thing again. Okay, so now it's going to ask me, do all the devices have the same username? In my case, it is no, so I'm going to say no. Do all the devices have the same default password? Again, no. Do all the devices have same enable password? I actually don't have enable password at all, so I'm going to say again no. Now the device host name. In our case, let's do for Nexus, right? We're going to pick this guy and let's paste it here. So that's a device host name. The IP address is 10.64.66.39, right? In my case, it's basically I'm connecting to my Eve devices, right? My devices which are on my Eve topology, and I'm telnetting it to it, right? Whenever you go onto your Eve topology, when you double click any of the device, you see on the left hand bottom corner, you can see that there is a port number, right? So in my case, it is 32770. So let's use that. So the port number is going to be 32770. So there you go. So that's the IP and the port number, right? In your case, if you're using the default telnet or SSH port, then you don't have to mention the port number. But in my case, since I'm connecting to the devices via basically the simulated devices, I need to do that, right? And username is admin, password is, I don't know, let's use admin, right? It's the same password, and the protocol is obviously telnet. The operating system is Nexus, NXOS. More devices to add. I mean, I can add here, but you see it's I have to keep on typing, right? So what I'll do is instead I'm gonna say do more devices to add. I'm gonna say no. Press enter, and there you go. The testbed file got created, and let's open this testbed file, right? All right, so there you go. I've opened the testbed file in my Visual Studio, right? And you can see this is how it gets created. So something which you need to be very careful is with the indentation, right? So you see this is the format of the YAML file, and it has to retain like this, right? Now what I'm going to do is I'm going to just use the same format, right, and I'm going to add my 2 of the other devices, right. I could have done it directly over there, right, by adding more devices using that utility, but I'm going to do it this way to show you that you can manually edit this file as well. So what is it going to be? In our case, it's CSR1000V, right, this one. So let's grab that and let's change this host name for the second one, CSR1000V. The IP address remains same. Let's check the port number. Port number here is 32769. So let's change this one to 32769. Right, telnet, all of this remains same. The username and password on these devices is Cisco. Right, so let's change that. And obviously this one is going to be iOS XE, right, because these are CSR1000V devices. Cool. Now let's again do the same thing. Let's copy the same section. Let's quickly go and dump it again and change this guy to what, 3, right, and the port number, let's figure out the port number. The port number is 32771. So let's change this one to 771. The rest everything looks good, right? So let's save that. It's already saved. Now if you want to quickly check if you have done everything right, there is a way to do that as well. I think it's called validate or something. Let's try that. So it's called pyATS. I think it's validate, and then you have to give the testbed obviously and the testbed file, if I'm not wrong. Yeah, there you go, right? So let's wait for this. If there are some errors in your YAML file, it basically shows up here, right? You see there are no errors. There's some warnings, but these are fine, and all your testbed devices are good, right? So that's good. Let's clear the screen a little bit. Also, while we are here, let me also show you what version of pyATS I'm running, because they release new versions I think every month or so, right, or every 3 weeks. I'm not exactly sure, but you can do pyATS version check and you will basically get to know. So say I'm running 20.12, right? So if you have some errors and if you're trying to talk to the pyATS community, maybe this will help you, right, to tell them that this is the version which you're running. Cool. Again, let's go back. So we have created the testbed file. What else? What next? Now there are 2 ways of interacting or using pyATS, right? One is inside your Python script, but you can also do it without that, right? And what I mean by that is, see, whatever we did till now, right, we were using the pyATS toolbox directly, right? We were not using Python at all. We were directly using the pyATS toolbox. So very similar way for connecting to the devices and doing your tasks, right? You can use the pyATS shell, right? You don't have to again use Python at all, right? So you can sorry, not pyATS shell. You can use pyATS directly without Python, right, to connect to the devices and do everything, right? So that's a way of doing as well, and we'll probably check that out maybe later. Give me a second, right? So we will check that out maybe the very next step, as a next step. But for now, let's get into what we call as the pyATS shell, right? So pyATS shell, let me tell you what this actually does. So pyATS shell, and what is the testbed file which we just now created? I think it's called again testbed only, right, if I'm not wrong. Yeah, there you go. So when you ignite the pyATS shell, what it does is it basically nothing but runs these 2 commands, right, which is nothing but it is loading the Genie testbed, right, and it is also loading the file which you just now provided, right? You provided this file over here, so it is going to load this for you, right? This is nothing different. So what I can do instead of doing this is I can do this. Let me split horizontally, and okay, I have to again go back to my pyATS folder. Let me source this. So that's why I always keep 2 terminals open so that I can do some quick testing, right? So now the same thing, if I want to do, what I can do is I can simply go and trigger my IPython here, right? So I can trigger my IPython and basically run these 2 commands directly here, right? And this one as well. Okay, so that's it. Okay, there's some error. Okay, because I'm not inside the that's the reason. Okay, let's go back. Let's go inside the codes folder, right, because that is where the file is. Let me go inside again, and this time let's load it, and there we go, right? So you see, it's nothing but the very same thing. What this one command does for you, which is pyATS shell, and providing this testbed file, right? It basically simplifies you running 3 commands, right? I had to now run IPython, then I had to import this testbed, and then I had to load the testbed. Instead of these 3 commands, what they have done is to make it simpler. They have bundled all the 3 commands into this one single command here, and that basically loads everything and gives everything ready for you, right? So right now what we are trying to do is we are trying to explore pyATS via Python. So right now we are inside Python, and we have loaded a couple of things. We have loaded the testbed file. Let's see. So what is this testbed file to begin with? If you see testbed, it's nothing but an object. See here, it's an object, right? It's nothing, it's like a regular object, okay? And we can do something like testbed.devices, right, to see what are the various devices, right? You can see here, you have the Nexus device, you've got the CSR 1000 V2, V3, basically all the 3 devices are visible. I don't know if clear works here. Yeah, clear works, cool. So that's basically it, right? You can see testbed is an object, testbed.devices, you can see the devices. Now what will be the very next step normally? If you want to connect to one device, right, I'll have to do something like, we saw that there are many devices. So what we'll do is testbed.devices, and let's actually pick one device, right? Which one do we pick? Let's pick the first one, probably this Nexus one. Let's pick this guy. Okay, I think that did not go the way I planned. Let me try it again. Let's put a code. Yeah, there we go, right? So this is how you can connect to the devices, right? So we saw what testbed is, we saw what testbed.devices is. Now we are picking one device out of it, right? And we are connecting it. Sys is not defined. Okay, let me fix that. Give me a second. All right, so I don't think it was an error. I think probably because I had 2 environments, 2 IPythons running, maybe it was kind of creating some kind of a trouble. So I just closed the one at the bottom, and now you can see I've basically connected to my device, which is Nexus 9001, right? Which is basically now stored in device, right? And how you can connect? You can do just simply device.connect, as simple as that, right? There you go. You see what it is doing? It is using all the username, password which we provided in our testbed file, right? And it is basically connecting to the device. So right now it is really connected. And what is the meaning of it is connected? Which means I can do anything on the device, right? Which means, let's say I can do something like output equals I don't know, maybe the device is basically stored in dev, right? So let's do dev execute, right? There are a lot of utilities now. So that's where, let me go back to the documentation and show you here, right? So on the pyATS, right, on the left hand side, you can see this is what you can do with pyATS. You can connect to the device. You can parse the output of the devices. You can learn some device feature. You can configure it. You can do some diff utility and so on. So this is basically what we are exploring right now, right? So yeah, so we are basically going to execute. What do you want to execute? Maybe let's run a very simple command, which is like show version or something, right? Let's try that. Device object has no okay, the spelling was wrong, my bad. Terrible with my typing. So yeah, there you go, right? So device.execute, it is running the command. There you go, we ran show version. We literally ran the show version command. And if you want to see the output, I can just do output here, and there you go, this is the output, right? But really this is difficult for you to use in your Python script, right? I mean, how would you you will have to write your own parser to do this. But this is where pyATS makes it easier for you, right? Instead of doing the same thing which we did before, right? We earlier ran execute, but this time instead of running execute, what I'm going to do is I'm going to change this to parse, right? So I want to change it to parse, and what I'm going to do here is excuse me, and I'll just change this to, I don't know, maybe something like parsed, right? Now let's run this. Okay, now let's see the output of parsed. This is useful, right? You can see now it is JSON. Now this is very easier for us to kind of, what you say, to explore, isn't it? To kind of use in our script. And one simple example of that would be something like, let's say someone is telling you, provide me the value of the memory, right? Or you want to use the memory value of this memory or this processor board ID. It's very easier to fetch that. How would you fetch it? You just go to parsed, right? And what is the outermost JSON key, which is platform, right? and let's go. This is basically nothing but a nested kind of a dictionary, right? So you just need to go inside one after the other. So we are inside platform, and from platform, I don't know, maybe let's go inside hardware, right? So you see this one basically ends. So this is platform starting from here, and then you've got like software which is ending here. So inside platform there is another key which is hardware. So let's go inside hardware, and so I can simply click on hardware, and you see I get so much, but I still have to go one more level inside because I need the value of memory, right? So I can basically grab this, paste it here, and probably go inside, I don't know, memory. If you want the value of memory, you can, you know, just get that, and now there you go, we have the value, right? So literally using this one single entry or one single, you know, I don't know, maybe hardly 4 words, I am able to grab the memory value of my device, right? Instead of me having to write a parser to parse all this output of the show command, we are in pyATS, we are exploring the already existing parser here, and you can see the output is already obtained in the JSON, and it's very easier for me to tinker with this, right? We could probably try one more. So what we'll do is let's try a different command. So what we were doing before was show version. Instead, let's try show interface, right? So let's try that. Oh, and I forgot. Okay, Nexus has a lot of interfaces, so it's going to take a minute or so to run, but you can see how quick it is doing. It's connecting to the devices. You could probably also see this on the device because I have console logging enabled. So there you go, right? So as we are doing it, it is getting logged on my console as well, and we can see everything which you know, pyATS is actually doing. There you go, it's done, I think. Let's check. Yeah, looks like it is completed. Now if I want to probably see the output of parsed, right, there you go. So you have the JSON key values, whatever, right? And let's say someone tells you provide me the output of, I don't know, maybe the MTU of this particular interface, which is Ethernet 1/28, right? 1/128. So how do you do it? You would go inside parse, right? You'll go inside the interface, and once you're inside the interface, let's find where is the MTU, right? So this is the interface, and the MTU should be somewhere here in one of these key values. There you go, right? So the MTU is here. So directly I can access it saying MTU. There you go. So we have the value of MTU, which is 1500, right? So also this is the reason why I like IPython, right? It gives you like a very nice interactive way of dealing with Python. So this is why, I mean, again, it's not compulsory that you have to use Python. You can use something else, whichever you are comfortable with. All right, so we tried that. What else? Let's also try something simple. Let's so we tried I don't know, maybe execute and parsing, right? We tried those 2 utilities. Let's see if we can configure a device, configure something. So what we are going to do is probably let's try to configure. So how do you configure? It's nothing but dev.configure, and first let's not configure anything. Let's just send some empty value, right? Basically we are not configuring anything, nothing explicit. We are just seeing what it does, right? So there you go. So when you go to the .configure utility, you can see how the prompt changed to conf mode, right? So which means it has the capability to configure as well. So what we are going to do is, which was this interface, Ethernet 1/28, right? So let's go and configure something. So what we are going to do is, we're going to say maybe we can send any command you want. So in my case, I'm going to send interface, and let's grab this interface, whatever this is, Ethernet 1/28, whichever we were playing before, right? So let's do that. Yeah, they were gone inside the interface, and next line, on the next line you have to put a /n, right? And let's put a description, right? We're going to put a description, and what is the description going to be? Something like bits please, right? Let's put the description as bits please here. All right, so that's good. Let's close this, and let's see if this configures. There you go, it went, right? We can double check what happened here, right? You can see pyATS has gone and configured it for me. I can again double check if you want. Show run interface, Ethernet 1/28, there you go, right? You can see the description has come in. So that's how easy it is to, you know, execute, parse, and configure your devices using pyATS. Okay, now whatever we did was till now was with Python, right? What if you want to do it without Python? So let's probably try that. So let me clear the screen a little bit. Let's grab this guy. Okay, So till now, like I said, we did it with Python, right? We did actually with interactive Python, it's normal Python, right? But there is also utility for you to kind of do it without Python. So if you're not familiar with Python and you want to still use pyATS, you can do it, and that's what we are going to check now. So you can use pyATS, and these commands you can use directly, like parse, right? Whatever we did earlier, right? We parsed show version earlier, so let's do parse show version, right? And let's provide the testbed file. And all these things are there in the documentation, right? I am just referring my notes here, but you will basically find all of this in the documentation, right? So we're going to say pyATS parse show version, provide the testbed file, and you'll also have to provide the output, right? Output, and the output here will be stored into a folder. So let's provide a folder, let's say snapshot 1 or something, right? So actually, you know what, let's run not just one command. So you can run one command like this, but you can run multiple commands also, right? So we can parse multiple commands. So that's what we're going to do. Let me show you that. So instead of just running show version, I'm going to do show version and show interface as well. Sweet. So show interface, yeah, there you go. So we are running okay, the problem here is I think show interface will not work on Nexus. Let me check that. Show interface, yeah, okay, show interface works here, but I think show interface will not work on this guy because it's a iOS XE, right? Let me just double check that. Give me a second. I think it is show interfaces here. Yeah, it's show interfaces. So what I'm going to do is I'm going to run 3 commands then. So let's do that. So let's run show interfaces as well, right? Okay, there you go. So what we are doing here is we are basically running these 3 commands, right, on all the 3 devices, and not just running, we are parsing. We are running it using the parse utility, so that output will be in the JSON format. Now what it is going to do is, since show interface is not supported on iOS XE, it is obviously going to give me an error or something, for iOS XE, but instead it will go ahead and run show interfaces on those devices. Similarly, show interfaces I think is not supported on Nexus. So for that, we are going to get an error, but rather it is going to run this for that, right? But I just want to capture my version information and interfaces from all my 3 devices which are there in my testbed. So that's why I put in all the 3 commands here so that it can run one after the other. And the output, like I said, gets stored in snapshot 1. So let's run this. So give it a second. Sometimes it's a bit slow. Connect to the devices. Has it already connected? We can check from here. Yeah, I can see it's doing something on the Nexus already, right? You can see some the status bar has come in. Yeah, so it's probably doing this on one of the device, and as soon as it does the task, it will give you some output about it, some summary, right? And then it will proceed to the next device. So it's going to take some time because there are, like I said, in Nexus there are so many interfaces, right? So it's going to, you'll have to run it through all the interfaces. So it's going to take some time. So there you go, right? It finished Nexus. You see what it did? It basically ran all the 3 commands for the first device. So it will do device by device, right? Whatever it does, right, in any of your test cases and everywhere in future as well, it's going to do device by device. So it picked the first device, it went and ran show version, show interface, and show interfaces. But show interfaces, you see, it said it could not find the parser because that command is not supported on Nexus. Rather, it ran these 2. But the same thing for CSR, it is obviously this one will error out, whereas show version and show interfaces were succeeded. And you can see all the 3 finished now. And let's check probably in my folder here. You see there is a folder called snapshot created, and inside the snapshot we will find all the files, right? Let's do LSAL probably, and you'll see there are a bunch of files. So there is connection file which is created, which is nothing but the same log which we have here, right? All the connection related logs will be there. The main outputs are always tagged with this parsed. You can see there is a parsed here. This is basically for CSR, the second device. There is one more parsed here. So these are the outputs we have to see. Like for example, I can just pick this guy, and or maybe we can just look it from our code here, right? VS Code. So here, there you go. Let me just grab this to the right. Okay. So let's look at the parsed, right? This is what I was talking about. So you see the parsed output is nothing but the JSON value. The console is nothing but the whole console, log, right? The raw output, basically the raw output of the of that particular command. So this is the parsed one, and this is the whole complete log which is seen on your console, right? So that is what it does, right? You can, coming back to our discussion, like I was saying, we really don't have to run it using Python, right? We can run it without Python as well. Now, just to show you another interesting utility while we are here, what I'm going to do is, there's a very interesting way of doing diff, right? You can see here there's a comparison of network states, right? You can do that, and that's something which I really like about pyATS. So what I'll do now is, let me go to one of the device, which is say this one, right? The Nexus 9001, and let's see. So show IP interface brief. What do we have? Okay, so let's see, show run interface, one of the interfaces which is 1/128, right, which we were playing earlier. Looks like there is nothing now. What I'm gonna do is or let me do one thing. So because I want to clearly show you how it is differing, so let me do one thing. So let me just or I could create a new loopback. No, I'll create a new loopback. I'm gonna say loopback 10, right? Let's give us some IP address to this guy. I'm gonna say 111, and 111, right? 255. All right, so there you go. So I'm gonna put that. Okay, I mean, I just want to do some change on my device, and I want to show you that it is able to capture the difference, right? So there you go. So I've created a new loopback now, and let's go back to the same command which we ran earlier, right? Let me clear the screen a little bit so that you are able to see, right? Let's run the same command as before. Let's actually go back, cd ... Yeah, so now let's run that pyATS command, but the same thing, I'm going to capture it into a different folder, right? Not snapshot 1, let's capture it into snapshot 2. Now let's wait for this to run. So I'll pause the video and come back once this is completed. All right, so looks like it is completed, and we should see that folder snapshot 2 as well over here. So now pyATS gives you this cool capability to do a diff. What I mean by that is, I can do pyATS diff and snapshot 1 and snapshot 2, right? So it is going to now compare. Basically, it will do kind of like a Linux kind of a comparison, and it's going to do complete comparison of both the devices, and it will try to find if there are some diffs, right? So here you go. So we've got some diffs, I believe. Let's see. So looks like these devices are all identical. This one also is identical. Looks like this one was there only in snapshot 1, but the one which I actually changed was this one, right? So let's check this one. So it is telling me the output can be seen here. So let's try that. What is it having? There you go, right? And you can see the difference, right? Basically that new interface which I just now added, you can see there is a plus mark along with it, right? And because I added the new interface, obviously there are plus marks around admin data, bandwidth, and all of that, which is very much perfect, right? Which is exactly what I wished for. Okay, so there seems to be one more diff here. I don't know what this is having. Did I change something? Let me see that. Cat. Let me just. Okay, that did not get pasted. Let me paste it again. Ideally, there shouldn't be anything inside this because we did not do any change, but looks like, okay, looks like there was some kind of counter changes, so that's why that also got picked up, right? There was no configuration change, but there was a little bit of counters probably changed. That's why. Anyway, so you can see, but majorly this is a very useful utility. It is nothing but your traditional Linux diff, right? But they have integrated inside pyATS so that you can use this in your code as well. So you can capture the pre-checks and keep it in a folder, and then doing the post-checks, you can do a diff and you can quickly figure out what are the changes in your network. All right, so next, the other interesting thing, so let's go back to the documentation. I keep forgetting what are the other things. Learn. Okay, so I think I forgot the learn one. So let's look at learn. So learn is a very interesting, again, utility. Again, all of this, whatever I'm showing you, can be done either using Python, or you can do it using the non-Pythonic way, where I'm showing it directly using the pyATS CLI, right? So let's do it by the CLI again. So we can do pyATS and learn, right? I can use directly learn here, and I can tell pyATS to now go and learn stuff from my network, right? So remember, I have what, BGP running. So I'm gonna say pyATS go learn BGP, and not just BGP, probably learn about all the interfaces as well. So I'm gonna say learn BGP interface, and let's provide the testbed file, right? You'll always have to provide the testbed file because pyATS need to know the device details, right? So that's that, and then let's store this in some output, right? And let's create a new snapshot folder. Let's call it as operations snapshot 1, right? So I mean, this is again one thing which I want to call out, or let's probably go to the documentation to actually show you that. So if you see here, you'll find something called models here on the left side, right? And these are the models which are already written, right? And I'm pretty sure they'll be writing more in the near future as well. So in the models, you can see these are the models which are written. Now we are looking at what, BGP, right? Let's look, where is BGP? Yeah, there you go. Let's click on BGP. Let's click on model. So this will tell us what they have modeled, right? For different platforms, right? They have for XE, XR, Nexus, right? They have created this. And let's go inside the ops structure here, right? So the BGP ops structure. So you see here, this is what they are doing. For iOS XE, when I'm telling my pyATS to go and learn BGP, it is basically running all these commands, right? So some experts, right, in the backend, they have verified and they have made sure that all the important commands for BGP are captured, right? Similarly for iOS XR and for Nexus, right? So this is why I like to say it is platform agnostic, right? So pyATS will do the job for you. You just need to tell your pyATS to go and run BGP, and it is going to internally figure out that for iOS XE, these are the things which are important. For XR, this is what they have to run for Nexus. So it's going to capture all this, right? And it is going to call it as a BGP operational state, operational structure, right? And let's run that now. So we are running two things right now. We are running BGP. Similarly, we are also running the interface. So here, there should be something for interface as well. Let's go back. Yeah, there you go, right? So this one. So we are running BGP and we are running interface. So let's run this. So we are storing that in ops snapshot 1. So let that run. So you can see it's learning BGP this and this, on all the 3 devices we are running, because we have BGP running on all the 3 devices. So it will be good to learn on all the 3 devices. So let's give it a minute. I'll be back once it is done. And you can see that has completed. So it has learned about BGP and interfaces and so on, right? We could quickly check as well, or we could probably check it on our studio here, right? There you go, right? So all of the information, right? So you've got the ops. You can see how in a JSONic way it has learned about BGP. So this is all done because they have already defined the model for BGP, right? So it knows exactly what commands it has to run, and it all stores it in a specific way so that you can and it's trying to make it as much as platform agnostic as possible, so that you can probably learn BGP from, I don't know, maybe tomorrow they can add Junos and other platforms as well. So that way you will learn about BGP the same way from all those different platforms, and it will be easier for people to use it in their script to do a diff and to kind of see where the changes are and all of that, right? So that was BGP, and let's look at one of the interfaces as well. There you go, right? So all the information about the interface is also stored. Sweet. So that's one of the diff utility which I wanted to show as well. Okay. So that being said, what else do we do? Next is probably we could I just want to show you probably a couple of scripts now. But before that, let me also show probably how you can do the same learn which we did. Let's also jump up here and let me try to do the same thing using what? Using my Pythonic way as well, right? So let's do that. So which device do we have connected now? We have the Nexus connected, which is fine. So I'm gonna do output, right? Output equals let's do device dot learn, right? And let's learn what? Interface probably, right? We are not running earlier. Remember, we did device dot execute, we did device dot parse, but this time I'm doing device dot learn, right? And you see the difference, right? Whenever you use the learn, it is basically using those models. So those models, internally have a bunch of show commands, right? It's not single one show command, it's a bunch of show commands for that particular platform which they have written. So all of those will get executed, right? So now we are doing learn. So there you go. It's running, it's gonna run a bunch of show commands now. Okay. So there you go, it's trying to do, I believe. Let's see what is happening on the device. Yeah, there you go. See, it not just ran the normal show command, but it ran a bunch of things. See, it ran IPv6 VRF, show VRF all interface, it ran show routing VRF all, and so this is all done in the background, right? So yeah, looks like my screen got a bit stuck here. I don't know what should I do. Probably close this. Let me fix it. Give me a second. All right, looks like it finally ran. So now if I want to see the output, what I can do is output, because it is learn, I'll have to do output.info. There you go, right? So all the values from the interface are stored in this model, right, in this way. And if I want to extract a specific value, I can do the same way like we did earlier. So I can pick this interface if you want, right? I can do output.info. Let's go inside that interface. And I don't know, do you want me to grab something important? What do we do? So let's grab this type, right? Let's see what this type is. So let's do that. Sorry. Yeah. Okay. Did I make a mistake? Let's try it again. So let's grab the interface. Right. So let's put that, and let's do the type. Okay, there you go. So we have the type, right? Very similar to what we did. So output, it's always easier to process output in JSON, right? And this is really how you can do it, because it's all nothing but it comes as a nested dictionary. So it's very easier for us to kind of go and get the required value out of it. All right, so probably let's do a couple of actual Python examples. I think you kind of got the feeling now, but let me still probably try out a couple of examples. I think I already have them stored here, so it will be easier for me to run it, right? So what we are going to do is let me show you one of my script, right? Let's call this as script 1. This is again on my, I've stored it. I've tried this before, it's in my notes, so I'm going to just directly run it for you here and explain what it does. But you know, it's very straightforward, right? You can probably write similar scripts as well. So let me grab that. Give me a second. All right, so this is one of the script, right? Pretty simple. So what is it trying to do? Remember these two lines which we talked about before? It is connecting to the Genie testbed, right? It's kind of importing it and loading the testbed file which we have defined. In our case, it is testbed.yaml. Then it is connecting to the device.connect. We did this before, right? And it is parsing the output, right? I mean, when we were trying that IPython, we stopped at this point, but now I have put some small logic here. So what is the logic here? The logic is it is trying to say which interface has CRC errors, right? So what it is trying to do is for every interface, right? It is basically seeing if the, let's look at that IPython output, right? You will basically be able to see it here. Yeah. So if you see here, for every interface, there is what we call as counters, right? So there is a key called as counters, and what we are trying to do is inside that counters there should be something called CRC errors, right? So what we are seeing is what we are doing in the script is we are seeing if there are counters for any of the interface, right? Output of the interface, and if it has CRC errors in the output as well, right? Inside the counters, it is also checking if we have CRC errors. And if CRC errors are present for that interface, then we are capturing the CRC error, right? How do you capture? We checked this before, right? Go inside the interface, go to the counters, inside counters, find the CRC errors, input CRC errors. And then we are doing if CRC error is greater than 0, we are basically printing it and using the dot format, right? Very common, straightforward way of doing it, right? So we are printing the CRC error. And if the interface doesn't have any CRC errors, we are printing no CRC errors, right? So very simple. I mean, we did till here before. I just added a small piece of logic here. So now we literally have a script ready which is going to provide us or which is going to tell us if there are CRC errors on any of the interfaces on my device, right? Let's run this. So for running this, probably let's do it here below. I really don't like running it from my VS Studio, so I'm gonna do it from here, right? So I believe the script is here. Yeah, there is that. So let's run Python script1.py. Right, so it is running. There you go. It is connecting to the device, and there you go. It's running all the interfaces right now. It's going through all the interfaces, and we'll have to wait for a second because there are so many interfaces here. Okay, still going through. Yeah, looks like it's done. Yeah, there you go. Right, so we have the final output as well. Right, you can see the final output where it is telling these interfaces don't have any error, and that's exactly what we wanted. Maybe, okay, right now I think we don't have even a single interface with CRC errors, but it's a good thing. But you see, we were able to run this. Now you might have a question, how do you prevent all this logs from coming up here, right? If that is your question, we can do that as well. So let me show you in the documentation where it does that. I believe it is somewhere here. Yeah, so I think it's in your connection. So I think it is called log std output or something. Yeah, there you go. Right, so there is a flag called log std output. Right, where is it? Where is the flag? This flag is when you connect to the device. Right, you can provide this a flag. So device.connect. Right, you can provide this guy as an argument over here, and you can basically put it as a false. So let me probably do that and show it to you. So what we'll do is let's go to the connect here. Right, let's grab that flag. Like I said, everything is in the documentation. You just need to search for it. Right, so there you go. Let's grab that guy and let's put it here and let's say false. Right, so now what it's going to do is it is still going to give me the same output, but it's not going to print all this junk which on the screen, right, except the final output. So let's try that. So script, right, I've started my script, and you see there is nothing getting shown on my screen, whereas it is actually doing the job in the backend. Right, look, it is actually connecting to the device and running the commands, but it is not actually throwing anything on my screen over here. Right, so yeah, while this is running, what we'll do is let's try the second script. So let me grab the second script. Give me a second. All right, so looks like this guy ran, and you can see we did not get any noise this time. Rather, we ran the script and you saw the final output being shown directly here. Right, we did not have any noise because we kind of turned off the logging onto the std output, right, standard output. Cool. The next script is I have it ready here. Script 2, right, where what is it trying to do? Very similar, right? You probably know this by now so much because we have done it multiple times. What we are trying to do is add another slightly different type of logic, right? This time we are connecting to the CSR 1000V, right? I think it is supposed to be V2 if I'm not wrong, right? So we are connecting to the CSR 1000V device. We are running show interfaces, right, on it. And what we will do is we want to shut the interface and do a no shut, right? That's what we are trying to do. So you see, for every interface in the output, we are checking if the operational status is what? If the operation status is present in the output and the output is equal to up, right? So if the interface is up, then what we are doing is we are appending it to a list called as to shut and to no shut, right? So we are appending it to both the lists, and then what we are doing is we are doing device.configure, right, and we are sending that list. So this list will be something like interface 1 shut, interface 2 shut, interface 3 shut. So that whole list will be present in to shut, and that we are providing it to the device.configure, and then we are printing saying that all the interfaces have been shut, right, and finally it is going to be, we are going to do a no shut. So maybe we can do like this. Let's just grab this one. So let's put that print shut all interfaces, and the same thing, sorry, Control C, let's put it here, and I'm gonna say no shut. So we are doing two things. The same interfaces which we shut, right, we are shutting it first, and the same interfaces we are gonna do no shut as well. And also I think this guy is away, so let's grab it this side. Okay, so that's good. Nothing very complicated as such. Probably you might need a slash in here, which is fine. Okay, so let's try. So what we'll do is let's go back here. Let's probably clear the screen a little bit, and we're going to say Python 2 this time. Okay, I did not turn off the std output or the logging for this one. So you can see the logging now. There you go. It is capturing all the interfaces related information. And once it has all the information, see, there you go. You can see it is shutting it now, right? And then it is doing the no shut. There you go, right? The job is done. See, first it did the shut interfaces, and you saw, so all my 4 interfaces got shut, right? Even the loopback, everything got shut. And then what it did was it went and ran the no shut part of it, which is the same interfaces it did the no shut as well, right? So technically, I think my BGP and all would have bounced a bit, but yeah, I think within that time, I think it just came back as well. So my BGP should be good now. Let's check that. Show IP route. Right, there you go. So I have the BGP routes here, so which means my BGP and everything is fine, right? So this is a very simple use case, right? What we did was we picked all the interfaces which were up, we shut it down, and we did a no shut, right? And you saw how quickly we could do this, right? So similarly, you can write any of your use cases, and you can use the pyATS in your scripts in the very similar fashion, right? Generally, your scripts would be something like this. This is your housekeeping stuff, right? You're loading the testbed, you're connecting to the devices, parsing it, whatnot, and then you have the logic part, right, where you write your logic, or you might integrate this with your existing script as well, right? Now again, whatever we did now were basically standalone scripts, right? But the next thing, which I don't know if I have time, probably I'll make a video on that, which is about exploring the test cases. Test cases was basically nothing but defining tasks, right, one after the other, and then making pyATS execute all those tasks one after the other, and then you also get a fine report at the end showing you what you have done and all the useful stuff around it, right? So hope that was useful, guys. So this was a very simple quick introduction to pyATS. Hope it was useful, and do check some of their other features as well, right? So, and do try out some useful or some existing code samples from their GitHub repositories, and it's going to be pretty interesting, right? Thanks a lot for watching. Have a good one.